Hello everyone. We're going to continue on the subject of wettability, and today we will talk about the classification. So the classification, we already talked about basically what wettability is, and we have a strongly water wet or moderate water wet, neutral, strongly oil wet, or moderately oil wet type of rock. Here we have another kind of classification for wettability, specifically for applied to the reservoirs, the petroleum reservoirs that we are dealing with. So the first category is basically strongly oil or water wet. So we have a reservoir. All the pores inside our reservoirs or what are highly water wet or very strongly oil wet. So that's one classification. Another one is neutral wettability, which there is no preferential wettability to either water or oil. So the contact angle is close to 90 degrees, and both phases have the same preference to be adsorbed to the surface or adhere to the surface of the rock. So that's the definition of neutral. But the confusing basically definitions are fractional wettability and mixed wettability, which actually happens more inside the reservoirs due to heterogeneous nature of the rocks. So what is fractional wettability? Fractional wettability means that some part of your reservoir is strongly water wet, some part of reservoir is strongly oil wet. This is due to different type of mineral compositions in different areas of your reservoir. Some mineral compositions are some minerals inside your reservoir are strongly oil wet, and some of them are strongly water wet. So you have a fractional wettability within your reservoir. So that's the definition of fractional wettability. Now, what is mixed wettability? Mixed wettability is basically the rocks that are smaller pores are water wet and larger pores are oil wet. Okay, so what happens? Why do we have such a situation? So let's assume again that you have two types of pores. One basically a small pore, another is a larger pore, right? So pore number one, pore number two. And small pore is water wet. Since water initially, if you remember, the wetting phase will fill all the small pores. So this pore is filled with water. Now larger pore, if it is initially water wet, so you have a layer of water here, right? And let's assume that you're in the oil is basically flowing through this pore, through the middle of the pore. As time passes, the thickness of this layer drops, which will be removed from the surface by the movement of the oil on the surface, and some other physical phenomena that is not in the scope of this course, but this layer thickness drops until a point that basically your oil will be directly contacting the surface. Okay, so your oil is in direct contact with the surface, and there are some active chemical components inside your oil that will change the chemistry of the surface of the rock and make it oil wet. So from a water wet, it becomes an oil wet type of rock, and the larger pores therefore will be oil wet, becomes oil wet actually, right? And the smaller pores remain water wet because it's filled with water always, and these water cannot be removed. Okay, so that's the definition of the mixed wettability. Now the next topic is basically two important concepts which are important to petroleum engineers. One is imbibition, the other one is drainage. Now we are familiar with the wettability. We are familiar with the concept of the wetting phase. Whichever phase that try to adhere to the surface more have more affinity to be adsorbed to the surface of the rock. And we are familiar with the non-wetting phase, right? So let's assume that you have a rock, right? Let's assume that you have a pore, and this is a water wet pore. So you have a layer of, let's say, water on the surface, and then you have oil inside, right? So you have oil inside. Now what you do is you will inject water. So let's say this is your water here, right? Now you inject water into this pore. So water is injected, right? What happens? It will displace oil, right? The pore will be filled with water and the oil will be removed from the other side, right? What happens to the oil saturation? Oil saturation drops, right? What happens to the water saturation? Water saturation increases, right? Now, I mentioned that your rock is a water wet rock, right? Water wet rock. Now, what is the wetting phase in a water wet rock? It's water, right? Because it's a water wet rock. What is the non-wetting phase? It's oil, right? What happens to the saturation of the wetting phase in this process? Increases, right? So such a process in which the saturation of the wetting phase increases is called imbibition. Okay, this happens usually during the water flood of a water with oil reservoir. So water flood means that you have an oil reservoir that it's depleted, the pressure has dropped, we don't produce much of oil naturally anymore. Let me try to draw. Let's say this is our reservoir, right? And we have a water injection wellbore, and then the water is injected to the reservoir to remove the remaining of the oil from the reservoir and produce it from a producer. So this is a producer, this is an injector well. Water is injected from this side, the oil is produced from the other side along with the water. Okay, so what happens during that process? Water is injected into the pores that have oil, remaining oil in it, and increases the saturation of the water. And if that rock is a water wet rock, then that process is a imbibition. It's called an imbibition process. Okay, so that's the definition of imbibition. Examples of that is water flooding again in a water wet rock. And we say that if water wet rock is saturated with oil, is placed in a water, the water will imbibe into the smallest pores, displacing oil. Okay, in a water wet reservoir, we already talked about this. Water will occupy the smallest pore, right? Due to the higher affinity of water to be absorbed to the pores, to the walls of the rock. And we discussed this as well. The larger portions of the larger pores will be, you will have a layer of water formed around the pore, right? And the oil will be in the middle of your pore, basically. So that's what happened in the reservoir, right? In an oil wet reservoir, oil will occupy smallest pore. We already talked about this, right? And this process that oil occupy or water occupy, oil occupies smallest pore in an oil wet reservoir, and water occupies the smallest pore in a water wet reservoir, is called imbibition. Imbibition is an automatic process of filling the pore without you really needing to put a pressure on your fluid to be removed. For example, again, remember that small pore that we talked about it, and we put the water in contact with this pore. What happens? Water adhere to the surface. You don't need to push the water into the pore. The water automatically try to be adhered to the surface, and it will adhere, continue to adhere the pore. That's how the waterfront advances. And then if the pore is small enough, what happens? Your pore is totally filled with that water, right? So this process is called imbibition. If you have, this is for water wet rock for sure. That's either water wet. right? If you have an oil wet and you put that oil wet rock in contact with oil, oil will do the same thing. It will occupy the pore, and then if the pore is small enough, it will fill the pore completely. You don't need to put any pressure to oil for it to fill the pore, basically. All right, so that is the definition. Drainage is kind of an opposite to imbibition. Drainage means that the saturation of the non-wetting phase increases. Okay, imbibition, the saturation of the wetting phase increases. In drainage, the saturation of non-wetting phase increases. Assume that you have a oil wet rock, and then you have oil here, right? Oil everywhere, kind of, right? You have that layer which is attached to the surface of the rock, and then you inject water into the pore. It will remove some of the oil from the pore, especially the oils on the middle of the pore, right? And what happens? The water saturation increases, the oil saturation drops, right? And since the oil is the wetting phase and its saturation is decreasing, or the water is the non-wetting phase and the saturation of the water is increasing, then this process is called drainage. Okay, examples: water flood in an oil reservoir which has an oil wet rock, gas injection into oil or water wet reservoirs because gas is always the non-wetting phase. And these are examples of drainage process. Another important example is when your oil reservoir is forming initially, and the oil and gas are migrating from your source rock into the reservoir. Your reservoir or trap is initially filled with water, and if your rock is water wet, oil and gas are displacing that water from your reservoir, and this process is called drainage, right? Because the saturation of the water is decreasing, the saturation of oil is increasing inside that water wet rock, and this process is called drainage. So next we will talk about implication of wettability.